Assalamu alaikum wa rahmatullahi wa barakatuh. Hi guys, welcome back to our revision. Today we are going to talk about complex numbers. First of all, before talk about complex number, we just need to review some important points. In the previous topics, or in grade 11, you studied how to solve the quadratic equation in that form: ax squared plus bx plus c equal to 0. And we know we just used the quadratic formula, which is x equal negative b plus or minus root of b squared minus 4ac divided by 2a. And that formula is very important and not given in the final. And we know that expression, b squared minus 4ac under the root, it's called discriminant. And we have, according to the value of that discriminant, to know what we have or what is the type of the roots inside that equation. So if discriminant has positive value, so that means I have two real roots. If the discriminant has negative 0, the value equal to 0, so the root it will be cancelled, so I have only one root, negative b over 2a, and in this case we say that it's two equal roots or one repeated root. But the problem if the discriminant is negative. Why? Because it lies under the root. We didn't have a square root for negative value, so we just do that. For example, if you have root of negative 4, what we have to do? If you have root of negative 9, what we have to do? We cannot do anything because no number multiplied by itself gives us negative. So in complex, we denote it for the root of negative 1 by I. So that means if you have root of any negative value, you can take that negative outside by I, and here we have root of 4. So I represent root of negative 1, and as you know, root of 4, it will be positive or negative 2. Also here, if you got any negative in complex, we take outside the root by I, and the root of 9, it will be positive or negative 3i. So we just use a complex numbers to solve quadratic equation which have discriminant negative, or to evaluate the radicals for any negative value. So now, what is the meaning of a complex number, or what is the complex number? A complex numbers are a set of numbers which contain both real and imaginary, and we denote it for it by z is equal. The real is x plus I y, where the real part here is called x, and the imaginary it's only y. So the conjugate of that complex number, we denote it for it by z star, and equal x minus iy. So in the conjugate, we just change the sign of imaginary part. Only we change the sign of the imaginary part. Assuming that if you have a complex number like that, 3 plus 4i, so what is the real? The real equal 3. What is the imaginary? The imaginary of z, it's equal to 4, not 4i. I, it's imaginary part. And you can plot that in Argand diagram. So what's the meaning of Argand diagram? Means always in the x and the y coordinate, x represents the value of real z, and the y is the imaginary of z. So in x and y coordinates, we have here x-axis represent the real, and the y-axis represent the imaginary. To represent Argand diagram, we just plot the point. For example, in this number, x here is equal 3 and 4. X is 3 and y is 4. To represent our Gantt diagram here, we just plot that point in x and y coordinate. So x here is equal 3. And y is equal 4. So that is our point. To find the Gantt diagram, we just join that point with the origin, which is 0 and 0. So the complex number here, it will be z is equal 3 plus 4i or i4. Sometimes in the exam, the Gantt diagram given, that he asks you to state the value of or the number or the complex number. So we just do that. We look for x first, it's represent the real, so it will be 3. Then y, it's represent the imaginary y, it will be 4. So the number, it will be 3 plus i4. So remind yourself, always, we solve any quadratic equation which you have negative discriminant using the quadratic formula, and we use I as root of -1. So you need to remember that always I is equal root of -1. So I squared, it will be equal, we squared both sides here, it will be -1. So I cubed, it will be equal I times I squared, so it will be -1 times I, it will be -I. And finally, I to the power 4, it's equal to 1. That values, it's so important to know it. For example, I have here worked example. He said solve the equation x squared equal 9. So for first one here, x squared is equal to -9. To remove a squared, we just take a square root. So x, it will be equal root of -9. So as you know, any negative take outside by I. So x, it will be negative goes outside by I, and I have here root of 9. So as you know, root of 9, it will be positive or -3 times I. For letter B, also I have quadratic equation, x plus 7 all squared is equal to -16. So to remove that squared, we just take a square root for both sides. So that means x plus 7, it's equal root of -16. If you have negative value, we just take that negative outside by I. So it will be x plus 7 is equal root of 16 times I. So that means x plus 7 is equal root of 16, it will be positive or -4i. Now I have two solutions because I have a number with the x here, 7. So we just go to do that. So I have maybe x plus 7 equal positive 4i, or x minus plus 7 equal -4i. So in the first one, we're shifting that to other side. So the value of x here, it will be -7 plus 4i. That is the first value of x. And here, we're shifting that to other side. So it will be x is equal -7 minus 4i. So we just noted that for any quadratic equation involving complex root, for that sign plus and minus, the complex root always come in pairs, a complex number and its conjugate, and don't forget that. So I have hint here. The complex roots come in pairs. A complex number and its conjugate. So for that, we notice the two solutions here represent the conjugate, negative 7 plus 4i and the negative 7 minus 4i. So if a quadratic equation have complex root, it's not comes alone. It must become in pairs, a complex number and its conjugate. And we state that from the formula because before the root I have plus and minus, and we know that a complex number x plus iy, its conjugate x minus iy, we just change the sign of imaginary. So now that is the explanation of the power I squared and I cubed. So we just need to know that I squared root of negative 1, sorry, I root of negative 1, I squared, it will be negative 1, I cubed negative I to the power 4, it's positive 1, and we work for that because anything to the power 1 or 1 to the power anything, it will be 1. For example, if you got like that question, I to the power 23, it's equal, and we have some choices like I or I negative I or 1 or negative 1. If we have like that question, it depends on the power. So since I to the power 4 equal 1, so if the power divisible by 4, the result it will be 1. So we just take that power and use a calculator. 23 divisible by 4, divisible means without decimals. Give me exact value, it's not divisible. So reduce by 1, 21 divisible by 4? No. 22? No. 21 not divisible by 4. 20 divisible by 4. So we can divide it like that. It's I to the power 20 times I to the power here is 23. So the remaining here it will be 3. Why? Because if the power divisible by 4, that represents 1. And as you know, 1 times I cubed, it's equal negative I, as you know. So the result here, it will be negative I, like that. Another example. For example, if you have I to the power 101, it's equal. The choices, it will be the same. Maybe I or negative I or 1 or negative 1. So always, if the power divisible by 4, it will be 1. So we check the power here. 101 divided by 4? No. Reduced by 1. 100 divided by 4, it's equal to 25. So 100 divisible by 4, so we just divide it to be like that. I to the power 100 times I to the power 1. That divisible by 4, so that equal 1. 1 times I, the result it will be I, and so on. Now simplify. To adding or subtracting two complex number, we just adding real to real and imaginary to imaginary. For example, if you want to add or just to simplify, for example, 3 plus 4i plus 7 minus I. To adding complex numbers, we just adding real to the real. That is the real. So here 3 plus 7, it will be 10. And imaginary with imaginary. So positive 4i minus I, it will be positive 3i. So if you adding or subtracting two complex number, we just adding real with real and imaginary with imaginary. Let's go to practice some questions here like that. Simplify the expression. Here I have 2 times 8, we just expand. 2 times 8, it will be 16. 2 times negative 6i, it will be negative 12i. We will expand 2 by every term inside the bracket. And here, by the same way, we're expanding negative 5. Negative 5 times 3, it will be negative 15. Negative 5 times positive 4, it will be negative 20i. Now we're just collecting. Real with real. Real, here I have 16 is a real. Here I have negative 15 as a real. So we're collecting the reals, it will be 16 minus 15 equal 1. And also we collecting the imaginary, which involving I. I have here negative 12i, I negative 20i. So it will be negative 12 minus 20, it will be negative 32i. In multiplication, also we multiply normally in letter P here. He said given two complex numbers Z1 equal and Z2 equal, find Z1 times Z2. So we just do that. Z1 times Z2 is equal. The first complex number 3 plus 4i times the second one, it's 6 plus 7i. So it's equal. We multiply normally, expand 3 by every term in second bracket. So 3 times 6, it will be 18. 3 times 7, it will be 21i. 4i times 6, it will be 24i. 4i times 7i, it will be 28i squared. As we know, I squared equal negative 1. So if you got any I squared, just remove it and to change that sign. And the focus for that is to change it from imaginary to be real. Then we collecting like terms after that. So it will be 18 minus 28, it will be minus 10. Now we adding the imaginary, which is 21 plus 24, it will be 45i. And that is the simplest form. So focus for that also, Mr. How to find the magnitude and direction inside complex. The most of topics in complex, it looks like the vectors. But always we work in vectors with degree, in complex with radians. So the magnitude of complex number represent the modulus. So for example, assuming that if you have z equal x plus iy as a complex number, so to find the magnitude of z or the length of z, we just evaluate the modulus, which is equal root of x squared plus y squared. To find the argue or the argument, we denote it for it by argue of z. First of all, I wanted to know the position. So in knowledge, that is real and here is imaginary. And the real take two values, positive and negative. Imaginary take two values, up positive, down is negative. If the complex number in the first quadrant, so the argue it will be theta. In the second, the argue it will be pi minus theta. In the third, it will be theta minus pi. In the fourth, it will be negative theta. Where always we substitute theta by tan inverse for y over x in positive value, only because we just use a sign to know the position. So for example, in the first quadrant, if you have theta, so that means only tan inverse for y over x. In the second, it will be pi minus tan inverse for y over x. In the third, it will be tan inverse for y over x minus pi. We just substitute every theta by tan inverse. In the fourth, it will be negative tan inverse for y over x. Similar vectors, but vectors in degree, complex in radians. That to find the magnitude and the argue. Now I have very important hint. If you have z is equal x plus iy, and the imaginary of that complex number, it will be x minus iy. So in general, the sum of any two conjugate, a complex number and its conjugate for any two numbers, it's equal 2 times real part only. The difference between the complex number and its conjugate always equal to yi. The product of any two complex or any complex number and its conjugate, it gives us only real part, x squared plus y squared. The modulus of any complex number equal the modulus of its conjugate. The argue of any complex number equal negative argue of its conjugate. Finally, the modulus of z1 plus z2 equal the sum of the modulus of the first one plus the modulus of the second one. It's a very important here you need to use in the tricky questions. And also don't forget that, and that is the most important because it's used in square root. The complex number squared, which is equal x plus I y all squared, is equal the real part always x squared minus y squared plus 2xy times I. If you memorize all of this, so you didn't have any trick inside complex. Now we are going to know how to divide two complex numbers. The complex numbers involving I, and the I, it's a square root or radicals, and in mathematics we cannot leave radicals in the denominator. So before we studied how to divide or how to rationalize the radicals from the denominator, if you have one radical or two terms involving radicals. So the most of complex number consisting in two parts, real and imaginary. So always, if you want to divide two complex number like this, 1 plus 7i divided by 3 minus I. We just multiply and divide by the conjugate of denominator. Why? To remove I from denominator. So here I will multiply and divide by the conjugate of denominator, and as you know, conjugate means I will change the sign of imaginary part. It will be 3 plus I and up 3 plus I. So you can use that rules I gave you before. In denominator I have to conjugate, and I told you that the product of any two conjugate always give us only real part, x squared plus y squared. So we didn't need to expand here. So the product of any two conjugate, it will be x squared, it will be 3 squared, plus y squared, the coefficient of I, it will be 1 squared. Not necessary to take negative here. But up, I will multiply normally, expanding. 1 times 3, it will be 3. 1 times I, it will be 1i. 7i times 3, it will be positive 21i. 7i times I, it will be 7i squared. So as we expand 7 by every term also. So now to simplify more, we just do that. 3 squared 9 plus 1, it will be 10. And up, we not focus for that. I squared cancelled and that changed to be minus. So we just collecting 3 minus 7, it will be negative 4. 21 plus 1i, it will be positive 22i. If you have only one term in denominator, we just split. Negative 4 over 10, it will be negative 2 over 5. Plus 22 over 10, it will be 11 over 5i. And that is the result of division. But focus for that also. If you have only imaginary part in denominator, we just need to multiply and divide by r. You need to multiply and divide by conjugate. We just multiply and divide by conjugate if you have full complex number in denominator. For example, if you have like that, 3 minus 4i divided by 2i. Here, it's only imaginary part in denominator. So no need to multiply by conjugate here. We just multiply by I over I. Why, mister? Because we multiply by conjugate to remove I from denominator. If it's a single, we need to multiply by I over I only. So it will be 2I squared. And here 3 times I, it will be 3I. Negative 4I squared. And as you know, I squared, it will be negative times 2, it will be negative 2. And here that cancelled, that it will be positive. Rearrange, it will be 4 positive. Then take the imaginary part, which is 3i. So the result here, it will be 4 over negative 2, it's a negative 2, plus 3 over negative 2, it will be negative 3 over 2i. So in division, if you have full complex number in denominator, we multiply and divide by the conjugate of denominator, like that. If you have only imaginary part in denominator, we just need to multiply by I over I, because we do that to eliminate or to remove the radicals from denominator, because I is the radical.